Okay, it's your turn. You've been looking at my code and watching me type, but now it's your turn to do some programming of your own. I have two assignments for you based on the information and the lessons in this chapter. You'll be able to draw from the example programs that come with this chapter. Both assignments require that you create and display a simple window with graphics in it, so you can use just about any program from this entire chapter as your skeleton starting point. Just be sure to change all the names of things to the new names that you're going to use. Everything that you need to do the assignments can be found in the example programs you've already seen. Well, almost everything. There are a couple of things that will be new to you, but they're not difficult, and I mention them in some of the hints that I'll provide in just a few minutes. The assignments are simple, but you'll find that you have to twiddle with them a bit to make them work just exactly the way you would like. But there's nothing out of the ordinary there. It's just one of the fundamental laws of software that as soon as you finish writing a program, you have to make changes to it so it will do what you want it to do instead of what you told it to do. In the next lesson, I'll be showing you my solution to these problems, so you can cheat if you want to. But if you don't cheat, I'll guarantee you that your programs will be entirely different from the ones I wrote. No two programmers solve a problem the same way. There's nothing wrong with that. It's just the way things are. Any program can be written in thousands of different ways, and no two programmers ever think alike. If any program you've seen so far were implemented by 500 programmers, there would be 500 distinct versions of it. And this is not a bad thing, it's a good thing. You start by thinking the problem through. Well, part of the way through anyway. Once you get your program written and working, you thoroughly understand how it works. If you were to use someone else's idea of the shape of the program, parts of it would always remain a mystery, and it would take you a lot longer to write the program. And you may not be able to ever get it to work. Just do your thing and see how it turns out. The first of the two problems is the checkerboard problem. Pop up a window that contains a 4x4 checkerboard pattern that completely fills the window. It's obviously made up of a collection of 16 rectangles in two different colors, positioned in such a way that the colors alternate. A simple checkerboard. Your first hint is that you should make the window square so the aspect ratio of all the rectangles it contains are also square, and the length of the sides of the window should be divisible by 4. That'll make it easier to place the start and stop side of each rectangle on a proper boundary. There are two fundamental approaches to this problem. You can either write the code to draw each square independently, or you can use looping to draw the squares. Either one is fine. That's up to you. Your second assignment is to paint a window that fades from one color to the next. The color should be at its darkest on one side of the window and smoothly fade to white before it reaches the other side. You already have almost everything you need to do this, and I'll be giving you a couple of hints here in a minute with the rest of the stuff you need. While fading from a color into white or into black is the easiest, it's also possible to fade from one color into any other color. If you prefer, you can fade to a color other than white. The only difference is the arithmetic you use to adjust the color values. Looping can't be avoided in this program. You'll have to establish a loop and create a new color object each time through it. You can make the rectangle as thin or as thick as you prefer, but thinner rectangles will make for a smoother color fade. You know that red, green, and blue values of the color object range from 0 to 255. The values 255, 255, 255 represent white. I mention this because in light, the presence of all colors is white, while in paint, the presence of all colors is black. But this is light, not paint. To be able to control the exact color values as you proceed from one to the next, you'll need to get access to the red, green, and blue values of the current color, change them slightly, and use the new values to create a new color object. You can extract the red, green, and blue values individually from a color object by using the three methods getRed, getGreen, and getBlue. If this is not entirely clear to you, take a look at the API documentation of the methods of the color class, and you'll find descriptions for these methods as well as other methods that retrieve color values. Well, that's it. As I said, I'll be showing you the solutions in the next lesson, but you should make a sincere effort to write your own version of these programs before you peek at my solutions. Even if you don't get yours working, attempting to get them working will make the solutions very easy for you to understand, since you dug around inside the problem yourself.